Hello everybody and welcome to this lesson. Today video I want to talk about what are the design patterns and why we need to use them. Today's videos I only talk about creational design pattern, but later on I can talk about another design patterns. Design patterns aim to, especially the creational design patterns, aim to help us to make a reusable code faster and easier. For example, me and David are working on the same projects, and David want to know how I create one object I wrote before. So if I write my object, especially the object that creating from them is very hard, like the communication between one product like a board or phone or Bluetooth or Wi-Fi connection to another device. David can easier understand what I done to write my code, and he don't need to read 1,000 line of codes to only understand what I how can create from my objects. So it can improve the efficiency of my code. And let's jump into the code. The first design pattern I want to talk about is a singleton. Singleton is make sure you create your object only one time in your entire project and not more. For example, in here, we have a server connection and we have to pass URL port, username and password. And every time we want to use that for creating server, we have to pass our parameters. But what if we want to instantiate it only one time in our project? What we have to, that's where the singleton is come in and try to solve our problem. In that case, I have a singleton class and I use it as a pattern on top of my classes. As you can see in here, if I delete the parameters from here and only initialize the first server, everything changes between these two servers are automatically changed in the anothers. For example, if I change the username in the second one, even in the first one, it will change. And in the entire of our project, we only have one class, not more, as I mentioned before. As you can see in here, we just connect to the first server, but its user it's changed. And all the parameters are shared between two servers. One of the design patterns we use in the daily programming day is factory. The reason why we use the factory is if we have one object with a lot of config into it, it's better to make one interface function or subclasses for creating that. As you can see in here, we have a car and it can have its own feature. For example, the first Lexus But in here, the problem is every time we want to make a class from Lexus or Benz, we have to define our class again and again and again. And if we want to use this particular code for example 100 times, it's really hard. So the solution is to define one factory and get the car type. If the car type is equal to Lexus, you can return this particular code. Otherwise, after we implement our car factory, we can say give me a Mercedes or give me a Lexus. The first one, okay, I think Benz. Or Mercedes. As you can see in here, instead of defining every time our classes, we just define it one time in a factory method, and every time we need that, we use it again and again and again. And it can get with that way we can make our code very faster and more efficient. Another design pattern we use them a lot is a builder design pattern, and the reason why we use them is that if we have one object with a lot of optional parameters and the parameters are immutable, we can use a builder design pattern. As you can see in the page, as you can see in here, we have a port type, port name, and baud rate. The port type can be serial or TCP, and the serial have a port name, but the TCP don't have a port name. So we create one builder classes. And instead of creating directly from our classes, we just create a builder. For example, TCP is equal to port builder. We need to set a port name, baud rate, priority, timeout, and buffer size. For that, we define the functions in our builder classes like port name, set port name. As you can see, the client of this class only can set and they can't get it directly. So set a port name. Oh my God. Can get a port type in here, and after that we can set our connection to port connection. Port name is equal to, for example, in here it can be TCP. We can pass it directly in here, and actually we don't need to set a port name because the port type, but we need to set a port name in here can be set. Okay, and self dot set no port type and port name in here. For the TCP we need to set port name, and the port name can be country, I think. Or it's don't have different one. Return self. As you can see in here, instead of setting parameters directly, we define one function, and this function set our parameters for us. And for connection, we define another function, connect. Self dot connection. Now I can print our connection in here. But we need to write other parameters. Let me to write them. As you can see, I have defined one function for each parameters in a connection, and now we can use them. For example, for TCP, we have IP address and port number and the parity. But in the serial ports, we have a different parameters like COM1 and the baud rate. The TCP IP is a port we write it in the here like that, and the port. But the serial port is the ports are open in here. I don't have any open port, but we can imagine that the COM1 is the open port of my computer. Of course, I should write it on a capital case. And as you can see in here, the important thing is those connections have the same structure, but they have a different parameters. We make them by just creating connection builder, and if we for every time we want to, for example, write every parameters for that and write it again, it's get a very long time. So this is the design pattern for Ajax, for web. In deployment, every day we can see this kind of design patterns. Especially for the connection between two servers, we can see the builder design pattern. I hope you enjoyed this video, and if you like that, I describe another design pattern, and my videos are about architects and web deployment. Please like and subscribe if you love.